Hi everyone, welcome back to my lab. I wanted to do a video on discussing the three elements of electricity in chapter 2. The first element is voltage, which is pressure, and it's measured in volts. And so here I have a power supply, and down on the right hand corner here is actually a voltmeter tied into this computer. I don't know if I showed that in my last video, but anyway, I have light bulb hooked up to this. And as I increase voltage, that light gets brighter and brighter. Okay. Also, if you watch the amperage here, running 2 amps at 11.7 volts, 1 amp at 4.3 volts. And if I keep increasing that voltage, I will eventually burn this bulb out. That little element can only take so many volts, amps, and that's just the way it's designed. It's designed for 12 volts only, or the automotive voltage. So I think that talks about amperage too, or current, which is the second element of electricity. But also wanted to go over high voltage. This is a stun gun. It's armed, that's why it's red. I don't know if it'd be easier to see this here. Okay, that's high voltage. And I'm going to turn it off so I don't zap myself. But these are based on that gap. Electricity can jump an air gap, and there's an air gap here. It measures out about a half a centimeter, and the rule of thumb is for every centimeter, it takes 30,000 volts to jump the gap. So if it's 2 centimeters, 60,000, and that's at atmospheric pressure here, not under any other abnormal circumstances. So this is about a half a millimeter, so that was a 15,000 volt spark. That spark's not going to kill you. It could. It could cause a heart attack. But basically what it does, it makes all your muscles contract horribly, convulsion-type contractions, and it's why it's so painful, and that's why it's a good defense mechanism. And but the other note I wanted to make is a lot of times they'll advertise these as million-volt stun guns. If there's only a half a centimeter gap, it's only 15,000 volts. Okay, so, oh, my thing fell off here. I don't know if I need this anymore anyway. So, that's voltage. Current is amperage, measured as amperage, and it's the amount of electrons flowing through a wire. So, say we have a fuse here. That's an inline fuse. We have a fairly heavy wire. The heavier the wire, the more current I can flow through this. Okay, so the matters on this is a 5 amp fuse. I could probably run 30 amps of current through this. So by changing that fuse, I can vary how much I run through here. A fuse basically protects this wire or your circuit. Okay, if I don't want to burn this wire up, I don't want to run anything bigger than 30 amps, because if I do and the current increases, it could actually start melting the wire. You can actually start fires and all that. Also note, current is what kills you. Okay, voltage is the pressure, current is the amount of electrons, and you start getting current through your body. It can burn your cells, and it burns, it kills. And that's why I can touch this circuit right now. It's only 12 volts. It's a very few amps. If I got a 500 amps in a 12 volt circuit, that's not going to kill me. But it can cause a lot of burning if I have a short circuit, which is the direct connection of a negative and positive wire. I can start fires and burn things that way. But when you start getting in the voltage above 24 volts and you got some amperage behind it, that's what kills you. And that's where safety has to really be. We have to start following safety. This spark here is, even though it's 15,000, there's no amps behind it. It's very, very small amps. So if that had higher amperage, number one, the spark would start changing color. It would be orange. And again, you don't want to try to shock yourself with this, even though it's low amperage. The voltage can still cause problems. The last element is resistance, which is measured in ohms. And I'm going to just show you a quick demonstration. If I hook up a resistor in line with this bulb, running about 7.8 volts now. Okay, that's going through the resistor, not through the resistor. Through the resistor, no resistor. As you see, it's going through the resistor, it drops the voltage. That's something very important we need to learn, is about voltage drop. And the other thing is, as that volt was going through this resistor, I already felt it, it started getting warm. Okay, and so that's where the other energy goes. That doesn't go through the bulb, it goes through the resistance, and it converts it to heat. So everything's based on amperage, voltage, and resistance, and we'll get into that more. This is kind of just a quick to show you what the book's trying to talk about, and then we'll definitely get into this more detail later on. So we'll talk to you guys later. Thank you.